Hello everyone, and welcome to today's SANS webcast. DNS evidence. You don't know what you're missing. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Philip Hagan, DFIR strategist with Red Canary, SANS certified instructor, and course lead for FOR 572. If during the webcast you have any questions for Phil, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to Phil.
Hello, welcome everyone. Thank you very much, Carol. I'm very excited to be here this afternoon, morning, evening, whatever time of day it happens to be where you are. I took a look through the attendee window. Looks like we've got quite a lot of folks from pretty much the world over, which is pretty amazing to me anyway. It's still pretty awesome. Well, we'll go ahead and get started. I also wanted to say, as we get started, before I jump in on the content itself, I'm very fortunate here to have a very good friend and colleague, Ryan Johnson, with us. Ryan, as you can see at the bottom here, this slide is going to be teaching FOR 572 in a number of upcoming locations. So it's always nice when we get to add a few friends to the mix. So thanks for joining us, Ryan. Glad to have you here.
Thanks, Phil.
Make sure my mice click. All right. So we are going to start out here today talking about DNS evidence in general. You know, this is something that I've been using for a very long time, and I know a number of other folks in the DFIR world have as well. But it's really starting to come into its own. And we're going to talk a little bit about some specific use cases, methods for collection, things like that. Definitely going to be a lot of fun, and I really also like to stress when I get going with any of these kind of webcasts that we're not pulling these ideas out of the ether, so to speak. These are all tried and true methodologies that we use in cases day in and day out. So whether you're talking about being in a traditional forensic shop where you're doing case-based analytics and evidence examinations, or whether you're in an IR team that's in proactive incident response throughout your environment, which the marketers call hunting, with great big air quotes around it. Regardless, this is stuff that is real world. We're going to show you some genuine stuff here and definitely give you some practical means of using it back in your environment. So just by way of introduction, Carol did a great job just with the initial throw. My background, I've been in information security for a very long time, and I definitely love it. It's something that I will continue to do for quite some time. You know, my background is in computer science and in the U.S. Department of Defense. I was an Air Force comm officer, and then after getting out, moved over to work in the consulting and contracting space. That's been for going on about 13 years now. As Carol mentioned, I'm also with Red Canary. We're a threat detection startup, so not directly relevant and related to what we're seeing in this material, but definitely a tangential security startup, and seeing a lot of great traction there. So it's a lot of fun. We've got a fantastic team. With SANS, I was very fortunate, very honored to be asked to be the course lead for Forensics 572, and I teach that around 20 sometimes per year. So as I say in class, I don't do anything for 22 weeks a year that I don't really love. So it's definitely a good time, and I really enjoy it. And I'll also ask Ryan to say a couple of words here and give us his background.
Sure. Really briefly, thanks, Phil. I've been doing forensics and information security since about 2003. I started out doing dead box forensics for police departments, working on cases from fraud to murder to drugs and guns. I left there and went to a lovely location in Iraq to work with the military, doing some media exploitation for combat devices that were collected. From there, I moved into consulting, where I got the opportunity to work on a lot more IR. That's my primary focus at this point in time. And I also was able to do some teaching for the State Department's Anti-Terrorism Assistance Program, their cyber division. From SANS perspective, I've been teaching 572 for SANS since last year. So I try and do that as many times as my schedule will allow.
Excellent. Well, like I said, we're definitely fortunate to have Ryan here. Got some good perspective we're going to be adding in here as we get going. And As Carol had mentioned as well, if you do have questions, please drop those in the question interface. We will get to those. I'll try to get to them during the presentation if they do come in and if we can slot them in. But we'll absolutely take a run through those toward the end of the presentation as well. Well, let's go ahead and start off and just say, well, why DNS in the first place? One of the reasons that I have always gone to DNS is that it is very fundamental. It is used by pretty much every other protocol. So if you don't know any of the several protocols that might be in use in your network, there's a really good chance that, at least for the TCP and the UDP carrier protocols, that you're talking about something that uses DNS. Very few pieces of software will use hard-coded IP addresses, except in very certain edge cases, most of which, in my experience anyway, are pretty suspicious in the first place. So when you're taking a look at one protocol to rule them all, so to speak, DNS becomes a great way to do that. So go to one location, go to one protocol, parse it well, and you're going to get really good value. Now, as you're probably used to, hey, when I look up sans.org or cnn.com or any other host name, it's going to return to you a series of IP addresses. That makes pretty good sense. But there's a lot of other types of records as well. A lot of times those will actually give us very good insight into how certain services are established, how certain authorizations are put in place, whether you're talking domain authentication for things like Google Analytics, or whether you're talking about SSH fingerprint pointers or raw text records that could be used for good or for nefarious purposes. But if you're looking at this traffic, you get a really good idea. Again, that kind of pulse, that kind of one place to go to see through a lot of different protocols. In addition, it's an old standby. It's very well documented, although it's somewhat convoluted in terms of how it actually lays down traffic on the wire. It's very well documented. There's a lot of very great, well-established parsers out there. So you don't really have to do a whole lot of reverse engineering and exploration. You can really get down to analysis pretty quickly. On the network forensic side, as I've said, we use it for that single analytic pulse, but it's real easy to see normal and abnormal. If you've got an idea of what the baseline of normalcy is, and we're going to show you some tricks that you can use to establish that within your environment, tactically or strategically, it becomes very easy to take a look and see which ones are abnormal, which ones are out of cycle, which ones don't belong to the picture. So that's one of the things that I really like about it, is because it's well documented. I can parse it with any number of tools, and it's basically going to light up like a Christmas tree if I see some stuff that's somebody speaking out of turn. And Ryan, ask Ryan to talk just a little bit on passive DNS specifically for a minute.
Sure. When we start talking about passive DNS when it comes to a incident response process, what we're looking for is some sort of normalized data set that contains historical DNS activity for our environment. There's, we want to be able to go back and say, okay, here was a request for a specific host name. What did that resolve to? And there's a lot of reasons we want to do that in an incident response or hunting, as we say with air quotes, process. One of the ways we can deal with this, albeit impractical, is to go ahead and just collect all the DNS records for every site across the internet. And of course, I'm being a little facetious there, because that's not it's not very practical. And because I grew up in Canada, I like to use the metric system in describing this. And we're talking about a bajillion or more of rapidly changing records. It's just not something that will work. So what we do in practice is focus on the DNS activity, or the DNS queries and responses that are happening in our specific environment. After all, I really don't care about sites and hosts that are out on the internet that are not actually being activated or accessed from my specific environment. So there's a few different ways that we can go about collecting this information. We can do things like pcap. We can take tools that are able to record traffic as it crosses the network and store that for later analysis. We can actually collect this information on each of our endpoints and then forward it in some way to a central repository for later analysis. And lastly, we can actually use the tools that are already existing in our environment. Most of the IDSs and proxy systems that we would typically find in our environment, would have the capability to actually collect this information in a searchable format. Now, the key here is obviously that we want it to be capturing the requests and the responses, along with some other information that we'll see in the next couple of slides. The best part about this whole thing is that it's really, really, really easy to collect. The cost associated with the collection minus the disk space is low, so we have an amazing return on investment for investigative purposes. It's huge.
Yeah, absolutely. And before we go on to the next slide, Ryan, I just wanted to circle back on something you touched on, which is really important. You know, we are, in this case, we're talking about capturing both the queries and the responses. A question had actually come in earlier about doing query log specifically on a particular implementation of a DNS server. And the reason we don't really talk about that so much is because historically, query logging was just that. It was just capturing the queries. And that's not something that you want to throw away if you have available, but if I've got the responses, that's something that's going to give me even richer information. And I think that's a good segue to kind of give you a real-world example, just from a practical perspective. So if I do a DNS lookup, reddit.com, I just do this here at the bash shell in my OS X machine, and you can see I get a response list of these 11 different IP addresses. Now, as far as why this happens and how it actually occurs, that gets a little into the DNS fundamentals. But the bottom line here is we've got 11 different IP addresses that are being used in order to provide service for the reddit.com hostname, commonly done for load balancing, for DNS round robin, for a number of other geographic kind of disparity type delivery networks. So this is really common. I mean, you run a DNS lookup against Google or CNN or any other major platform out there, and you're going to get a bunch of replies back. Well, the challenge to us becomes, well, how do I pivot this information, this host lookup? Which IP address does the client use to make a web connection? If all I'm looking at is the query, I know that it looked up Reddit, but how am I going to pivot into a NetFlow log? How am I going to pivot into full packet capture at that point? I've got to actually know which of these IP addresses it is. Making things even more complicated, these IP addresses by RFC are returned in random order. So there's no deterministic way of identifying which direction this is going to be. Is it going to be sorted or unsorted? Because it's 100% random. So that's a very important distinction to make. So what we like to do is take a look at the passive DNS records. Now this is an example coming out of a utility that's simply called passive DNS. I'll give you a link to that a little bit later on here. But this is standardized records, and you can see, let me bring up my pen here, that it has a set of separator characters, hopefully you can see where I'm circling in red, that happens in this case to be the double pipe. You can change that. This is just the default. I ran this on a collection against my home network here. And it was exactly the same lookup that we just showed you on the last slide. So I did the DNS lookup for reddit.com. And you see that in this case, my syslog includes a variety of data points. Now these data points are standardized. That's the key. I really want to stress that because they're standardized, normalized records. They're really easy to parse. You can feed this into your SIM. You can drop this into, we've got an ELK VM that we use, Elastic Logstash Kibana VM we use during the class that I distribute outside of class as well. Tons of different places we can use this, but the data points, the fields themselves are very standardized. And you know what, let me clear my pen here so that's out of the way. You know what, I'm going to do this. There we go, we'll get rid of it. So I want to look through one of these records and show you exactly what all these fields are. The very first one, well, anybody that's been through the class or has been hanging around the forensic world long enough knows that that is a timestamp. This is the number of seconds, and in this case sub-seconds, that have elapsed since January 1st, 1970 at midnight UTC. Just the way a lot of Unix systems keep time. So in this case, it's a 10-digit integer on the whole number portion of the decimal point. It starts with a 1-4, indicates that it's a fairly recent timestamp in this case. But we know that is also something we can pull out of the source code to confirm. Well, the next value that comes across in this log, we see the client's IP address. Now, I really want to make an important point here. This is going to be the IP address as it's pulled off of layer 3 on the packet that this utility, the passive DNS utility, sees. I should probably also state this passive DNS utility best run on an endpoint as a daemon, or it could be run against a tap. So you can take a tap port and you observe that traffic, or you can feed it against pcap, as I'll show you in a little bit. But it is going to see the layer 3 address. That's what's going to be logged. So if you're natted, you're going to see the post-NAT address. There's nothing that's going to pull out the true endpoint IP if it has been natted or translated in any way. We get the client IP address, certainly that's helpful. And we get the server's IP, which server provided the answer. Well, in this case, this again is my home network, 75.1, happens to be my default gateway. It's a device that I've got here on-prem. And that's actually acting as my DNS cache, my caching DNS server. Now the class, this is going to be IN. IN means that it's an internet class of query. There's a bunch of other classes. They're very rare. I'm not going to get into them here. But what's nice to know is that if you did have anything that was non-internet class, it would actually be logged as well. Now it actually gets a little bit more interesting. So in this case, the next field, we're going to get the actual name. This is exactly what the name is that was requested. We did a lookup previously and received information back. We got the www.reddit.com query that went out, and then it was sent out in one packet, but you'll see that we've got multiple entries here. I'll get to that in just a minute. Multiple entries in the reply. Each record also includes the record type. In this case, we made a request for the address record, which in DNS RFC explicitly states that that's called an A record. And then we get the response back. So these responses, remember we had those 11 responses that came back in for that one query. So those responses, each different answer back gets its own line. Now, if you look over in the, grab my pen again, if you look over here in the left-hand side of all these results, you'll see those all have the same timestamps. Well, that's because they all came by in the same response packet. So realize that you're getting multiple entries for those multiple responses. Now, the last couple of values are also interesting from a forensic point of view. First of all, the TTL. This means how long should any intermediate server, such as my internal gateway that I use here on the premises, on the perimeter of the house, how many seconds should that DNS cache keep this field, keep this value in place? So in this case, 297 seconds, so just under 5 minutes. And then the last one tells us the record count. I mentioned the fact that there were 11 records previously. Again, those are going to be reflected here, so we know we're looking for 11 records. But again, this is extremely useful information because not only did I get the fact that the query was made, which is what you used to get if you enabled query logging on Bind or Microsoft DNS or any of these other server platforms, I'm getting every single response back, which is hugely valuable to me as an investigator because a lot of times the visibility I have is limited to layer 3, layer 4 when you're talking about something like NetFlow. We'll give you a couple of use cases for this as well coming up in just a minute, but let's talk briefly on how we're going to actually leverage this against our other types of evidence. We've got one here. Ryan's got another one we'll come up with in just a minute, and we'll talk through some collection methods for that. So what I've got here is a couple of records out of NetFlow. This is also NetFlow I'm collecting on the perimeter of my house here. And don't worry too much about what the exact command line is. It goes beyond the scope of what we have for the presentation here today. But the thing to keep in mind is NetFlow has no content. NetFlow is just a statistical aggregation about a connection that was made in the past. We're generally limited to see things like the source and destination IP address, the layer 4 protocol, the source and destination port, as well as some other metadata like timing information and things like that. Now what you'll see here, I've got two different records that I've displayed. The first one is, grab my pen one more time, the first one is between an internal IP address, this 192.168, and an external IP address using port 80, which is this 5.79 IP address. So this external IP address is something that maybe I want to get a little more information about. You know, is that an evil command and control node? Is that you know, a content delivery network? Is that sans.org? Well, I could do a reverse lookup on it. That's maybe an operational security risk, not necessarily something I'm going to go to first. So that's going to be a last case. If I've got passive DNS available, I can actually do a lot better. You'll see in this case is I go into my passive DNS logs and I simply grep for that IP address, that 5.79 IP, and we'll see that I get this dcs.cb.phillips.com. Well, if I'm may not know exactly what this is, if I don't know what the endpoints are, I at least know that now it's communicating with Philips.com, major electronics company. Maybe it's a television. Maybe it's a some other device that that Philips has here in my house. Well, I did a little bit more digging, and this actually is the Philips Hue light bulb bridge. So I've got a couple of internet addressable, internet controllable light bulbs, just because it's an occupational hazard when you teach network forensics that you have a whole lot of weird devices on your home network to see what they look like. But what we'll see here is I can actually characterize the nature of that connection. Don't need the content, don't need to look at the host fields. If I don't have a web proxy to try and characterize that port 80 traffic, you know, I've got still some very useful visibility. Now, let me go to the second example before I show you what that one looks like. This 108.168 IP. You know, in this case, it's actually communicating. This was my system communicating while I was looking through VPN, connected through a VPN to the house. But we'll see here that there's a number of packets that were communicated, but not a lot of data. You know, this is actually a hallmark pattern of activity for potentially command and control check-in. Because if I've got lots of packets that are very small, that may be something that is worth looking into. Well, before I spend the time to go dig in and actually figure out where all these communications were, let's go ahead and take a look at what the host name is here. And what we got to do here is, again, grep that IP address out, and then we'll see that this time I've got something on the discus.com domain. Now, a little bit of open source research shows me that discus.com is actually a provider, a service provider, that allows you to insert comments on web pages. Now, first of all, I like to think humanity is a pretty good thing, so I never read the comments on the website, period. I rarely do. It's just kind of something I do to maintain my faith in the good of humanity. But at this point, it's something that was actually going on in the background, so I'm able to characterize it. Is it malicious? Probably not, but I've at least got that visibility. And before we go on to the next one, I see that there's a question here. So a question did come in from Christopher on specifically means of capture. We're going to talk about that in just a minute in terms of some different ways of capturing it. But you specifically asked if Security, Onion, and ELSA can do this. There are probably about 752 different ways you could capture this. So there's absolutely a possibility you could do this with Security Onion. You can do it with Bro. You can do it with T-Shark. I use Elk with Logstash, like I mentioned. So there's a lot of valuable places that you can get it. We're just going to focus on a couple of them just for the sake of the webcast. But yeah, you're absolutely right. And then I will throw it to Ryan for another example.
Sure. Thanks, Phil. So in this example, we're sort of getting our toes into the water around what I refer to as the first boogeyman of network forensics, and that is encrypted traffic. So in this particular NetFlow, we see the source IP 23.246.5.135 communicating across port 443 to one of our local internal IP addresses. And we see there's a lot of packets and a lot of data. Now, you know, one of the things we talk about in class is NetFlow is an abstraction. It essentially gives us, as Phil already mentioned, sort of metadata about the traffic that's going across the network. So if we're looking at this, we can't tell what's going on in the traffic. There's no visibility into that traffic. We get that with NetFlow, but we also get that when we're dealing with encrypted traffic. And we hear quite frequently during class, it's encrypted traffic, just ignore it. There's no benefit. We can't see inside of it. I respectfully disagree, and we will disagree at length over that. Leaving aside the fact that it may not actually be encrypted traffic going across port 443, we can use very similar or the same tactics that Phil used in the previous slide to try and get an understanding of what this is. This is a lot of data coming from an internet host down to our local network, so we want to have a look and see if we can discern anything. So if we grep our passive DNS logs for those IP addresses, again the 23.246, we come back and we pick up a single record that has a second order domain of netflixvideo.net. Looking through open source intel or gathering open source intel on this traffic, we see that this is actually affiliated with with Netflix, and this is actually streaming information coming down. Now, we may not be able to see what's inside of it, and in this actual case, it is encrypted traffic, but it will certainly allow us the ability to give it the sniff test, to really get an understanding or a feeling of whether or not this is something to be concerned about. One of the most important things that we talk about, and something that has served me very well in doing incident response, is being able to sort of understand what looks, what I call funky, and what's not funky. And so this allows us this sort of transparency.
Yeah, absolutely. And that brings up another good point too, and the reason that we had decided to use Netflix as this example is Netflix, along with a lot of other of these new, very flexible elastic service providers, they will spin up hundreds or thousands of systems in a very short period of time to handle surges in demand and then spin them back down. So for example, you might see connections out to the IP address that happens to just be an Amazon EC2. No way to tell exactly what that is. The reverse lookup of the IP address is not going to necessarily get you back to anything related to the service provider. It's just going to tell you who the hosting provider is. So being able to find out basically how did this client, in this case the 75.28 client, connects to this remote 23.246 IP address. Will it reach that through the use of this host name? So another good example of why that transparency, encrypted or not, is an important one to make. And we've touched on this a couple of times too, about the use of DNS as an intelligence benefit. Some of the things that we're starting to see, and again, I'll be really kind of honest here, you look at the term hunting with air quotes, as we've said a few times so far, it's really just a mature IR program. It means you are actively out there looking for compromises that you didn't necessarily know exist. Some people call this the assumption of breach model. Some people call it, the hunt teams. So whatever you want to call it, we're really talking about what metrics do you have in your environment already that you can start tracking in order to establish these baselines of normalcy so you can real quickly, easily identify where the deviations are. And I think DNS is a fantastic example of this. So this little bit of shell gymnastics that I've got listed off on the right-hand side is really just a way that I can go through all of my entries and my passive DNS entries, and I can look for what the top and second level domains are for each query that was there and give me a nice histogram, a nice sorted list of the most common top and second level domains that are seen in my environment. So in this case, what we'll do is if you can't right now, let's just say your environment where you're sitting or where you're working today, if you can't right now tell me what the 5,000 or 10,000 most commonly used second level domains are in your environment, then you absolutely need to go out after this webcast is over and figure out a way to start collecting that, because that's going to help you understand when something changes. And when that changes, you've got to really spring into action. That becomes the reason you start investigating. Because the first time you see a domain, very first time ever, a second level domain, you better wonder why. And you better have the team, process, the technology available to figure out the answer to why that showed up new, because it's a very good chance that could be used for malicious purposes. Now, even more malicious or suspicious is if there's a domain that was just registered yesterday and it shows up in your environment today, that's something you need to know. So you can't do that unless you have a list of domains to start with. So when we talk about hunting or assumption of breach or these proactive IR, continuous IR engagements, we're talking about a last stage in the process. So it's something that your mature IR team is going to have, but you've got to start collecting that now, because if you're not collecting your baselines, you're going to be in trouble. But the thing is, on this little bit of shell gymnastics that I've got over on the right-hand side, this is actually something I ran off of one of my servers. I run a small fleet of VPSs, mainly just to get some visibility on real-world scenarios and real-world traffic patterns that are out there on the internet. And the first thing I saw is, holy cow, this is weird. I've got a significant number of inadder.arpa lookups. Now, if you're not familiar with that, no problem, but inadder.arpa is actually what's used for reverse IP lookups. So anytime I do a lookup for an IP address and I get an answer back, it's actually converting that before it goes out on the wire to an in-addr.arpa lookup. But when we see that, it means I'm doing a lot of lookups of IP addresses. My first thought was, holy cow, why is this happening? This looks unusual to me, because I hadn't looked at it in a while, I'll be honest. It was something that I collect in the background, and I haven't had the need to really dig in on this evidence just yet. Well, I took a look further, and I realized that one of the ways I'm doing spam prevention and things like that on that server is through the use of gray listing and through the use of reputation checks on IP addresses. Well, it does this through looking up the IP address, which ends up being an in-addr.arpa, and it looks that up in a variety of online reputation databases. So at that point, that's something that I said, okay, this is not only normal, this is good, it's preferred. Now I've got a new idea on a rolling baseline. I kind of traced this back to find out why it was surprising to me. Ends up I had enabled a new reputation check a couple of days prior to when I pulled this information, so it was still showing up as unusual, not something I'd seen before. But once again, seeing what that normal behavior is, seeing what the typical layout and ratio between all of these different domain names is going to be a great means of hunting and profiling and baselining for your environment. Well, we're going to pivot real quick into how to capture. Now, I've mentioned before I get in on this slide right here, I mentioned before we're specifically not talking about query logs. We're specifically talking about doing passive DNS monitoring. Now, you can do this a variety of ways. You can do this with full packet capture. You can do this with dedicated utilities, third-party services. We're going to touch on each of those. But I definitely want to clarify again, we're not talking about enabling query logging in Bind or turning it on through the registry hacks in Microsoft DNS server or anything like that, because none of those are going to give you the responses. And the responses are really the pay dirt that we're after. Well, it wasn't too long ago, going back onto the slide here, that our main means of collecting this evidence was through the use of full packet capture. Hey, if you want capture, if you want to see what your DNS traffic is, you've got to run a command like we got on screen here, using a capture utility like TCP dump. And we've got a couple of what I'd consider to be practical collection options here. So I'm looking for a snapshot length of 0. It means capture all traffic. Of course, I'm assuming I'm legally permitted to do so. The dash uppercase G tells me that I'm going to rotate my output files, in this case after every 1 day. It's the number of seconds in a day, 86,400. And instead of displaying the content to the screen, I'm going to write it out to dns.pcap. And after a day goes by and this rotation kicks in, we're going to see that that dns.pcap adds a new file called dns.pcap1, dns.pcap2, dns.pcap3, etc., etc. Now at the very end here, I am using what's called a Berkeley packet filter specification, or a BPF. That BPF in this case says I'm only looking at traffic, and I'm only going to be putting traffic into this output file that is using port 53. Now we are here using TCP and UDP, because if you didn't realize it, DNS traffic, although it typically rides UDP, it can just as well ride TCP as well. So if you've got a DNS visibility solution that is not including TCP, you're definitely going to miss the boat. There's going to be some scary stuff that's going to happen on TCP that you probably want to be aware of. And I've definitely seen attackers in real-world compromise situations that have evaded detection through the use of TCP53. Well, this is all good and well, and if you know anything about full packet capture and parsing pcaps and trying to bring them up in Wireshark or some other utility, it's great, but it's going to require some post-processing, because I'm not going to get what I showed you previously, which is that nice standard normalized format of an output log containing all those various fields that we found to be so interesting. So post-processing, not bad. If we have to do it, we can standardize it, but it does mean that we've got an extra step. Now, I would actually recommend actually, that we would go ahead and do this proactively. I think that's a direction that we would want to go, and we'll show you a little bit on how you can do that in just a minute. Make sure we don't have any questions here. All right, we are in good shape. So the post-processing can actually come in a couple of different forms. The first example that we've got up at the top here, I'm using what I would consider to be my favorite packet handling utility, which is T-Shark. Now, if you're not familiar with it, T-Shark is Wireshark. It just runs in a shell. I like to say if it doesn't run in a shell, you don't need it anyway. And I do stand by that. I think that all the real work, all the real forensicating is done in the shell. But what we've got here is a T-sharp command that reads that pcap file in, and what we're doing is writing out individual fields. Now, you can do a man page on this later on and kind of figure out what all of these parameters are. The bottom line is, instead of me outputting a whole bunch of information about each individual packet that's seen, I'm just pulling out some specific values. So I'm saying I only want to look at the response packets, and for each response that comes in, I want to print out a few fields. So the first field is going to be the time value. Now, it's not as machine parsable as we saw with passive DNS, which we'll get back to later on, but it is present. So it's helpful. It's going to tell us what that UTC time is when that was observed. We've got now the IP address that's the destination first, and then the source. And the reason that we include those in that order is that the destination is going to be receiving the response. Again, we've got this $Y up at the top, and that Y parameter tells us that we're just looking for the response packets coming back. So that's why we've got destination first and then source. So here's the system that received the reply, and here's the system that had made that response in the first place. And then in this case, we're looking specifically for what the response name is, so that's going to be the query that was made, and then we see the DNS.A record. Now, this is a little kludgy and hacky, so I want to just bear with me here. In this case, I've explicitly stated, just show me the DNS.A records. Instead of saying, show me the CNAME, the aliases, show me the MX, the mail service, show me the NS, the authoritative name service, show me the text records, any of these other things that may have come by which would have been included in the previous logs that I showed you. In this case, I'm going to have to run one query for one command with T# for every single query type. Not exactly manageable. It's scriptable. It's something I could easily do if I had to, but I would prefer to go as directly as possible to something that's real easy for me to handle, real easy to parse. And in that case, we're going to dip over to the passive DNS utility. Now, I've got the URL listed down here. I tried to make it easy. It's for572.com/passive DNS. That's actually going to forward you off to a GitHub page for a user on GitHub named Game Linux. It's just the handle that he or she goes by. And I love this utility because it's very small, it's very lightweight, super easy to compile. I think it takes me about 3 seconds to compile the whole darn thing on my systems here. And it does provide the output that I showed you previously, and it will, as I've shown you in this case, read from a pcap file, so those pcap files we created with TCP dump before, or it can read from live network interfaces. So here in my home, I've got, I mentioned NetFlow collection and things like that. I'm also collecting passive DNS in real time, and I'm feeding that directly into my ELK VM, where I can archive up a couple 100 million of these responses and query across them very, very quickly. So really recommend that's the direction that you head. And I think this, whether you're using this passive DNS tool or, as was mentioned previously, something like Security Onion, or I touched on Bro, or whether you're pulling this off of a proxy server like Ryan had mentioned, if the proxy server has the ability to pull passive DNS info, or maybe you're even running this passive DNS utility, whether it be on a tap or you can run it on an endpoint. Many, many possibilities, the deployment of which go beyond the scope of what we're going to hit in this webcast. But you get the idea that a standardized, normalized value is exactly what we're looking for. And let's see, before I go any further, I saw that a question had come in. I want to hit that here. Would you want to hit packet size as well to look for anomalous traffic like hidden channels? You know what? Absolutely. That is definitely a visibility gap you would have with passive DNS through this utility right here, because it's only going to show you these fields. But again, I've got to go to the fact that I probably have a 500 million to 1 ratio between normal DNS traffic and the suspicious DNS traffic. I'm going to at least go to some kind of information about, well, if it is an oversized packet, I'm probably more interested in the host name itself, which is then going to drive me to want to do focused collection. There's always that what if. That's a tough one to answer, but I would say that it's usually going to be normal DNS traffic. It's something that we can use very effectively just through the use of these standard records. So when it comes to collecting, we also have another option, which is commercial services. Now, of course, you know SANS is not commercial training. We are very vendor agnostic with everything that we provide, but I throw out a couple of options here that I think are at least worth looking into, because I know a lot of the folks that work at these organizations, and I've used them in practice in some cases, and I've got a really good feeling with where this industry is going as a whole. That all being said, I could make this slide look like an F1 racer's fire suit or a NASCAR driver's fire suit with logos. You know, we're not talking about these three in particular as the only ones out there. There are dozens. Definitely think that you should do your homework on this before you decide on a commercial provider. But the benefit that you get here is that a lot of them provide their information by APIs, meaning I can programmatically ask them at some point in the past, what IP address did you have for the sans.org hostname? And they'll go back into their databases, take the entire data collection, sometimes from across all of their clients, and it's going to give you an answer, which is really helpful because I can go back in time without having to, without needing to have had that collector out there proactively. That said, of course, we certainly profess the need for continuous monitoring and you know, continuous visibility to support continuous IR actions. So we certainly would want you to also consider a service that allows you to place your own sensor in the environment that you control, and then it will be able to archive those in a queryable form off-site on their platforms as well. You know, some of the intelligence that these folks also add, and the one that I will say that I do have specific experience with regard to the work that I do at Red Canary, is the Farsight nod, which is newly observed domains. We've really had a fantastic result with them, and basically amounted to any time we see an incident involving a domain that's less than a certain age, a certain number of days, there's like a 95% chance in our overall visibility stack that that is at least suspicious, if not outwardly malicious. So that gives us a real good visibility there. So you get an idea to the type of intelligence you can get, especially when you're talking about someone like you know, an OpenDNS, Passive Total, Farsight, you know, any of these large providers out there that are going to just have literally billions of records. I was talking with, or heard a talk from Andrew Hay. I can't remember the exact number of queries he saw when he used to work at OpenDNS, but it was something in the billions per day that they would observe, which is really a pretty amazing concept. You think you've got big data issues, you know, this certainly takes that to a whole new level. And then the last thing that I'll hit on before we move on to the next slide here in terms of use case, question had just come in on, can passive DNS scale to large networks, specifically 10 gigabit plus? You know, I haven't tested it at that level, so I'm not going to be able to say definitively yes or no, but you know, that probably is going to be stretching its limit. That being said, if you're running passive DNS, the specific utility that I talked about, against captured data that you've pcapped, it may be able to, it may not work in real time, but you'd certainly be able to pull that information out. When we're talking about a typical forensic environment, you know, complete comprehensive parsing is treasured far more than immediacy. We'd rather have accurate information to ensure that our findings are correct. But if you are looking at doing 10 gigabit plus, you're probably going to be looking at something that's a little bit bigger of a solution. I don't know. It very well may work fine given the right platform. It's just not something that I have the opportunity to test out. So let's give a quick use case, and then I know Ryan's got one coming up as well, and I think we're doing really well on time. So you know, one of the things you may come into contact with is this notion of a fast flux architecture. And if you've used it before, you're probably already wincing in pain because you know what an absolute pain in the butt this is to investigate and try and clarify. But if you haven't seen it before, fast flux is really nothing more than a clever way of saying malicious load balancing in the pursuit of concealing the bad guys' platforms. So what we got over on the left, I've got it labeled bulletproof web hosting, which just basically means hosting that the bad guys pay for and they buy it from providers that aren't going to really take them offline if they do bad stuff. So it's kind of like hosting resellers that don't care about the acceptable use policy. Well, even though they're not going to get booted offline, of course they're probably not scared of going to jail in the first place, they still want to keep that bulletproof web hosting as long as they can. It costs a lot of various currencies that you might use in some of these countries where cybercrime runs rampant in some of the former Eastern Bloc nations, and to be honest, globally. But what they're going to do is they're going to lease a botnet. So these compromised hosts I've got down the middle here are part of a botnet. And the bad guy out there, he's going to lease these. He's going to probably pay with a stolen credit card or a fraction of Bitcoin or something else. And they're going to basically lease time in order to forward traffic. And it's going to just be a little tiny piece of code that runs on these compromised hosts in order to forward traffic. So it's really acting as a NAT device. What I want you to do is consider what would happen on the query side. So our little client down here at the very bottom, the proverbial laptop, makes a query out for evil.org. Now when that query comes back, it's going to actually say, oh, well, that evil.org, it exists at this 101.202 IP address. So the client's going to say, sure, no problem, I'm going to form a request, I'm going to go out to 101.202. Well, of course, this little piece of evil that's running on that compromised host is going to NAT the connection back to bulletproof web hosting, receive the response, and then broker it back to the client. Now I want you to think about what you and I will see in this situation. If our visibility is right where I'm striking this red line here, all you and I see is a single query and a single response that appears to be going out to the 101.202 IP address. Now maybe we identify this, and you and I look at it and say, aha, that's bad, let's block it. Let's go to the firewall team, let's get rid of it, let's block that traffic. So we block the IP address. Well, what's going to actually happen, and this all is automatic, the bad guy is going to actually change the IP address that's responsible for evil.org, and he's going to change it over to this 75.19 address, which means that next time our little victimized client here in the bottom needs to communicate outward and establish command and control connectivity, it's going to do a DNS lookup for evil.org, receive the response, but it's going to get the 75.19 address now. And at this point, the client's going to reach out to 75.19. Now, if you and I have visibility on the second red line that I'm striking across the query response pair, then we're going to think we found a new command and control server. Now, what's happening, of course, is it's still being brokered back to bulletproof web hosting. Same server still responding, same server still doing everything. It's just that you and I think that this is two different systems. Well, you get the picture here. This is going to then scale linearly. And although I only have 3 compromised hosts in the botnet shown here, that's really going to be hundreds, if not more, and it's going to be very, very, very fast. So the challenge for us is that, man, if I could only get an idea for what this evil.org is actually going to look like in my evidence, I could find where all of the different connectivity was. Well, sure enough, as you might expect, passive DNS records are going to help us out there. And if I'm looking at the passive DNS records associated with the activity that I just explained on this notional fast flux architecture, don't say that 5 times fast on a webcast, everybody, but the fast flux architecture is going to call that out in a hurry. Now you can clearly see, yes, we've got evil.org reflected in all 3 of these entries, but I've got all of my IP addresses that were used for all of those connections showing up right here in Crown and Glory, and we can now go back and look at something like NetFlow, find out where they connected to. Maybe it was something in an HTTP proxy, so we may be able to look for evidence of those artifacts in HTTP if it was reaching out to that via web connectivity. We've got time values. We've got the ability to scope in the clients, so we got an idea how many clients and which ones and where they might be were engaging in this type of fast flux architecture. So altogether, that gives you really good visibility. Now, the question that just came in is, I'm going to, let's see, you know what? A question from Bill. I wanted to acknowledge that I've got that from you. I want to answer that one a little bit later. So just give me a minute. We'll absolutely hit you back on that because I want to give Ryan a chance to hit this next example as well. Off to you, sir.
Thank you. So an additional use case we have when it comes to command and control is what we term phased C2. This is a situation where we will, and we've seen this quite frequently, where an attacker sets up a command and control server or fleet of servers, and they decide to go off, or they have to go off and operate on another attack campaign. And while that original, excuse me, that original campaign is not being actively exploited or actively used, they'll change their DNS records to either point to a non-routable address like a 10 dot address or something of that sort, or they'll actually set it to the loopback, which is what we see in the in the example, the passive DNS example on the screen. So if we were looking at a local system's DNS cache or a typically configured DNS server, their cache, all we would likely see is the last entry, which says that evil.org resolved back to a 127.0.0.1. And that's odd enough on its own. I mean, we don't typically see, unless we're responsible for it, we don't typically see external DNS requests resolving back to loopback. But that really doesn't get us very far. So looking at the rest of this, we see, well, we have an 18, our TTL is 18. Typically, again, this is with a fair amount of sort of, or it depends. Typically, we see TTLs in the 300 range, the 5-minute range. So that resolving to loopback, seeing a low TTL, seeing a single record return for evil.org, those are all things that are suspicious. Now, if we have the opportunity to have this DNS information historically, we can look back and see that, not too long ago, evil.org actually resolved back to that 75.19 IP address. And, that in context would be, or should be, something that sounds the alarm that you've got something weird going on. And definitely it's something that we would want to look into. My typical next step would be to go and find out who else tried to resolve evil.org, who else, or what the IP addresses were, and then look through every record I could find to figure out who else was also communicating with those IP addresses. So we've got a fair amount of visibility that this can provide to us just having the historic information online.
Absolutely, and that's a great point too. Is having it historically, how long can you keep this? It's pretty cheap to obviously we're not talking about bargain basement storage from Fry's necessarily, but you can keep this stuff for a very long time because it compresses extremely well, and it's not really that large to begin with. So very, very good, very, very good use case. Before I run on to the next slide, I did see a question come in. Zach, you had asked for the link again. I went ahead and pasted the link itself into the chat. If you need it verbally, it's for572.com/passive DNS, and that will get you where you need to go. But I've put that into the chat window as well for you. So those are a couple of use cases. This really just scratches the surface. This is something that is finally, I'm pleased to say, finally coming into its own in terms of being used in proactive and even after the fact IR engagements, whether you want to call that hunting or just robust IR. Anything that we're doing in the investigative sphere, we're always looking to improve our game. And this is a great way to do it. I've been looking at this for years, and I love seeing a lot of these new utilities and kind of disruption in the market to see all these great new platforms and solutions that are coming out. But as I said, this is one tiny little sliver of the puzzle. It's a very important one, I think. But we talk about, we've got a number of courses coming up, and we talk about everything from NetFlow to full packet to log aggregation. We go over the ELK VM, and which you could use for both NetFlow and log aggregation itself. We really have a lot of great material. And I'll also say that of all our classes, we're about 50% hands-on. So our workbook is 300 pages of hands-on, true evidence, actual skill development. So we don't necessarily just talk about it. We're gonna actually put it into action. You're gonna leave this class with some real practical knowledge to either start applying back the day you get to work, or you could absolutely make my day. I had a student a couple of classes ago who I think on like the second or third day of class, they said, I've got a case that I've been working back at work. I VPN'd back to the office and started using this stuff right away. So we've actually had folks using it before the class is even over, which is great. As you see on the right-hand side here, we've got a certification from GIAC as well. That's something you can pick up to get the acronym after your name and show that you've got the chops in this particular arena of network forensics. But we've got a lot of these other classes as well. I've got mine that are listed here. Ryan's got some coming up. If you've got a chance to get to Washington, D.C., that's going to actually be the best time of year to go to D.C., to be honest. The weather's going to be great, but the schools aren't going to be out yet, so it's not going to be crazy overrun, crawling with tourists yet. So it's definitely a good one to check out. Plus, it's a summit, so you've got the chance to sit in on some fantastic talks surrounding the training itself. Definitely one that I would recommend checking out. But there are probably about 15 to 20 more events this year. We're going to definitely be someplace near you. We've got events going in Europe. We've got events in APAC, Australia, Singapore, you name it, as well as across the U.S. So a couple of questions have come in. I want to take a chance to answer these. I realize we are about 6 minutes into before the end, which is fine. You know what? Somebody just came up with something. Thank you, Zach. You know what I'm going to do? I'm going to let you go ahead and I'm going to change on the fly because you know what? Editing slides while you're in the middle of a webcast is a great idea. Zach, you get 17 imaginary points. I don't know if they're good at your local retailer, but it's for572.com/course. My apologies for that. So definitely check out the full list that we've got going on. But I want to answer some of these questions. If you need to duck out, we're going to keep recording until all the questions are answered. You can always come back in and hear them later. Or I'll be able to stick around for a couple minutes after. I always book up some extra time because this kind of stuff generates great questions. So the first question that I'll mention here, it sounds like TCP dump. Bring the question up. Sounds like a TCP dump should be running on the servers, on the DNS servers, and if your servers are Windows, can WinDump keep up with it? You know, I actually would say a better deployment mechanism would be to put a tap in front of your DNS server and then take the revenue port of the tap and put that into your passive DNS collection solution. Now, I run passive DNS itself on my endpoints that don't share a DNS infrastructure, so I know that that will work to a reasonable level. But on the Windows side, you know, even if you're just talking about your server, a lot of admins are going to get pretty twitchy about running yet another utility against the server. So that's one of the ways that I mitigate the risk that comes along with that. Whether or not it's a real risk, it's perceived. So I'll usually put a tap in front of the DNS server and try and do it that way. But even still, if you're collecting that live with passive DNS, you don't even need the storage to do the full packet capture necessarily. And I think that that's really the most bang for the buck. Did you have any other thoughts on that one, Ryan?
The only thing I would say is if when you're talking about, you know, capturing this by pcap, you know, the birthday packet filters are your friend here. If you wanted to put TCP dump in place for the purpose of capturing this information, restricting it down to port 53, both TCP and UDP, would make that as small as humanly possible. So it's certainly an option and a reasonable way to go.
Yeah, absolutely. So let's see, a couple other questions have come in. 2 from Dallas. I'll hit these in order for you, Dallas. Questions on NX domain entries. You can, with passive DNS and with a number of these other utilities out there as well, you can explicitly ask that it does log NX domains, which you're very great. That's a great way to potentially see odd things going on, because if you've got a system that's making 20% of its requests are coming back as NX domain, maybe you're looking at a domain name generation algorithm, there's a lot of possible angles of why that might be bad. So I would say just evaluate your utilities before you operationalize them, of course, and in doing so I think NX domains are a great record to make sure you can hit. And then, where's my cursor? You had also, Dallas, asked about recommended free tools to parse Windows DNS logs. I would just say roll your own. But I want to give you a big caveat there because remember, if you're taking Windows DNS logs, those are query logs. Those are not query and response logs, so you're not going to get the full complement of passive DNS data. I would say it's much better to go with something that's going to be truly passive instead of relying on and hoping that Windows is going to log that for you. But in terms of actually doing the parsing, I have done that both in terms of bind and Windows before. We have bind query log parsing that's built into the ELK VM that I've mentioned that we use for class. We've got a couple other parsers that are out there as well. So your mileage may vary. I would just say you'd be much better off going to a true passive DNS solution though. Let's see. Let's see. Questions on, here's a good one. Ryan, maybe you've got some thoughts on it especially the second half of this one. Kevin's asking thoughts on using Silk and if there's any recommendation for open source intel. On the first part, which I can definitely answer directly, Silk, if you're not familiar with it, is a very large-scale NetFlow collection architecture. It is open source. It is free. I know a lot of ISPs and folks inside the DoD and the U.S. government at least like to use it. It's a very well-designed software, but it's not going to necessarily get you the visibility that we've talked about here. It is going to be reliant on NetFlow alone. So if you have time to invest in deploying it and building and maintaining the architecture, I think it's very worthwhile, and I think it can rival a lot of commercial NetFlow solutions as well. But it isn't necessarily something that you're going to get in the in terms of passive DNS visibility. And then on the open source intel side, I'd actually throw this to Ryan and see if you've got any thoughts on it. My first thought is always to go check out what has most recently been known as emerging threats. I find their IP lists to be pretty good, but I didn't know if you had any thoughts on intel.
Sure. I think the emerging threats is great. You're going to get a lot of false positives out of that. But the way that I do this, and really my process is to reduce my scope as much as humanly possible. So I will take massive quantities of passive DNS data, and I will compare that to something like the Alexa top million websites, and get a data reduction so that my scope is a little cleaner, a little finer, and then I use that as a methodology to sort of figure out what needs to be investigated, and then I'll go. I mean, Farsight is a great thing to look at for newly registered domains. So I think that's the process that I would go to. There's a lot of versions of open source intel out there. Emerging threats being probably one of the best.
Yeah, so Dallas had also posted a comment in here recommending checking out DShield. That's another good one. Thanks for that thought process. I know the SANS ISC, the Internet Storm Center, has a number as well. Not to make it all about classes, but one of our newest classes in the forensic curriculum is 578. It's all about using and creating threat intel. I haven't had the opportunity to take that class yet, but I'm really excited about it because I know there's a lot of very useful things coming out. Thank you very much, Ryan. So let's see, the question came in about the LQVM. Yeah, I should have thrown that in the slides. I put the link into, I tried to, it didn't actually link for me. But the LQVM is downloadable. It is free. It's something I distribute outside of class. I will send out a tweet with that as soon as I'm offline here and my fan calms down. I'll pin that, but there is a link mostly in the chat here. It's for/log/readme. Yeah, my chats have been a little unhappy. So yeah, log/readme is the one that's going to get you where you need to go. Like I said, I'm going to put that into a tweet. It's something I recommend you check out. A little bit of sneak preview in the next probably 2 to 3 weeks. We're going to have a brand new version of that VM out. So doesn't mean not to check out what we have now, but do stay in touch and stay aware of when that new VM is released out. And then the last question that I have in here anyway, unless anybody else asks any others, is is DNS authoritative any better? Well, it depends on if you're talking about authoritative or if you're talking about something like DNSSEC. So authoritative DNS is just going to be the NS server, the DNS server that is explicitly permitted to answer on behalf of a certain subdomain or domain. So for example, the NS records that are authoritative for the sans.org domain. It's just part of the DNS infrastructure. Now in terms of DNSSEC, I haven't seen DNSSEC catch on. It will be authenticated, which is going to improve the ability to trust DNS, because right now you're trusting a plaintext protocol over UDP, which is about 17 different kinds of odd and concerning. But so authenticated of any kind DNS is going to be a little bit more what I would consider trustworthy. I wouldn't say secure. but it would be a little bit more trustworthy. But that's a whole different era. You know, I don't think we're going to see the tide turn on that for quite some time. So, Manuel, to your question, you know, it is nominally better, but I couldn't really quantify exactly how much better that is. Any other questions at all? I get a little indicator if people are typing. I don't think I'm seeing any. Well, let's see. Before we sign off, Ryan, is there anything else you wanted to add in, talk about SOC Summit or Boston, your events coming up?
Well, I know that we're, pardon me, I know that we're a little past time, but if anybody is coming to or in the DC area in May 19th through the 24th, love to see you at the SOC Summit. Likewise, I'll be headed back to Boston in early August for one of my favorite events, the SANS Boston event. So if you're in the area, by all means, come on by and say hello, and that would be great.
Excellent. Well, thanks everybody for sticking around those couple extra minutes. Our contact information is up here. Please feel free to drop us a note if you do have additional questions. The recording for this will be posted and available to you in probably, I believe, a day or so. Might even be later today. Just depends on the backlog that they have at the shop. I appreciate your time, and thanks very much, SANS, for putting this on. And then I will hand it back to Carol to play us off.
All right. Thank you so much, Phil and Ryan, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks very much, everybody. Appreciate it.